Welcome back to a lecture series on hydrogeology. So, in this lecture, now what we are going to discuss about the groundwater recharge. So, this is the major factor. I think nowadays everyone will accept that we have to save the water. Where the savings comes when atmospheric water collects, and then you have to save it when the water comes to atmospheric or meteoric media. So we are in position to collect the water and save the water. That is the way only for us to escape. So during precipitation, either during winter or during summer or during season, when the water comes, you have to plan in such a way that you have to allow the water to pass through or get it infiltrated into the subsurface to recharge the water table. Otherwise, in future, there will be that huge amount of people will be there in the water scarcity region. So that is the prediction by many hydrogeologists in the future that if the situation goes like this, I mean extracting the water continuously without the knowledge of sending the water down to the surface, then this will impact negatively to the future generations. So concerning this, groundwater recharge is the major media in the future. So what is artificial recharge? It means you have to made a structure artificially, not from the natural source, and you have to send the water. When rain comes, you have to send the water down to the surface. Is called artificial recharge. Apart from that, when the water goes inside, water also transmit through the trees by evapotranspiration. It goes, and by evaporation it goes, and this is the precipitation, and this is the runoff which enters into the river. I is the media where you have to plan in such a way to stop the water for some time, so that the water will penetrate down or slowly gets into the system. Naturally or artificially, this we have to plan. Either naturally available region also we can plan. Actually, artificially also we have to plan. The water may be added or abstracted from the zone of saturation, send it to the down. So that is called recharge. If the water is added to the saturated zone, is called recharge. If the water is removed from the saturated zone, is called discharge. It means pumping water for your use is discharge. It means lowering the water table and I mean recharging the water table. Elevated ground with deeper water table constitute the recharge area. Elevated ground with deeper water table, it means a hilly terrain, constitute the recharge area. Whereas the topographic low, it means low-lying area with shallow water table comprises natural discharge. So this is a reverse relation. It is high hilly area. So this itself acts as the recharge zone, because where the water level is deeper. In a plain region or in a low-lying region, the water table is near to the surface, where it is acting as a natural discharge. Simply a region supplying water to confined aquifer or unconfined aquifer is known as recharge area. It means you have to send the water from the atmosphere, from the surface to the ground, is called recharge area. So these are the different parameters as we have studied in the hydrological cycle, but especially what you have to see here is the recharge. As and when rain comes, slowly you have to allow the water to get into your system to the groundwater saturated zone. This is called recharge. The plant will take, that is plant uptake. This is unsaturated zone. This is land. The water goes back by the process of sun interaction with the plant and the surface water. The surface runoff. Sometimes the water will be supplied to the stream also. And this is another diagram that how we will recharge. Sometimes you will have to make a pump. It is called injection pump. It means how you are making injection for a human being when they are not feeling well. Similarly, you have to send the water. You see the here the cone of depression. This is cone of upheld cone of things, because the water is recharging into the groundwater system. This is a good idea in many countries. In islands, they have started doing this. So they are maintaining the water table because it will not, so that the seawater will not come into the picture of it. So this is groundwater reservoir, sand and groundwater. This is sand. This is surface runoff during rain precipitation, and you are allowing the water to get into your system, and this is the water level. So artificial rechargeable is being nowadays being practiced in most of the coastal regions to arrest the seawater intrusion. What is the principal sources of natural recharge? Normally, precipitation, stream flow, lake and reservoirs are considered as the principal source of natural recharge. And the presence of pebbles, gravels, sandbed, unconsolidated formations, wherein you will get higher porosity and permeability, allow the water to penetrate down to the surface to reach your groundwater system. Apart from this, faulted, fractured zone in rock formation and the presence of sinkholes in limestone, right? This is in sedimentary formation are good places for recharge. And the absence of barriers in the groundwater flow, that is very important. The groundwater flow should not be arrested. So that region is also considered as a recharge zone. What is the significance of groundwater recharge? Right. Significance of groundwater recharge due to increased extraction of groundwater. It consequently your responsibility is no to recharge the water also because you are continuously extracting. And what will happen? It leads to adverse salt balance, crop failure, seawater intrusion in coastal aquifers and land subsidence. This all will cause if you continuously pump the water or if you are not bothering about the charging the water down to the ground. It's like how we are doing charging when we lost the energy in battery in our mobile. The economic development, rapid industrial growth and population explosion have increased the demand of water resources. To solve the above problems, the recharge of water into the aquifer is very much essential. Artificial recharge of groundwater is becoming increasingly important for groundwater management and in conjunction with the surface water and groundwater resources. Quality of recharging water is also to be considered. You cannot send the bad water into the subsurface to pollute already existing good water. Recharging water should be free from suspended biological contamination. It should also free from dissolved air and otherwise it will create air binding. It is also should be pure and free from silt and clay. Otherwise, what will happen? Your suspended sediments will arrest the movement of subsurface in the groundwater system. Permeability will last. Must be free from sodium content. Otherwise, what will happen? Deflocculation, and there is a process called in water purification occur. And again, you have to do purify the water. The temperature of recharging water may be slightly more than the aquifer water to get better results. Yes, that is also temperature of the water controls many times the chemistry of water. Coming to the many methods, there are many methods of charging the water: digging pits or shaft, construction of percolation dam, seepage tank, injection or recharge wells, incidental or unplanned recharge, induced recharge, and finally the spreading method. This is the general method: naturally available basins, channels, flooding, irrigation, and ditch and furrow method. So this is there are major 6 methods, and in which the digging pits or shaft. This is digging pit of shaft. You see, you have a clay soil, you have a permeable material, and you have to send the water to the permeable material so that the water will go down and then percolate down to the water table. So you have to make a shaft. You have to make a dig first pit, make a pit, and then make a shaft. Stop a water for some time over here. Automatically, the water will slowly goes into the aquifer system. That's what it is explained here. The shafts are vertical opening in the ground. This is called shaft in the ground to reach the ore body or recharge the water. If the previous formation are found in a very shallow depth, the recharge is done by digging pits. If it is a little shallow depth, you have to make a pit and or shaft. Sometimes if it is impermeable layer, may encountered at shallow depth between the surface of the water table of this. So this is how normally you will be having for about 2 to 3 feet. There you have to make a pit and then make a shaft also. As the impermeable layer lies above the saturated zone, the spreading method of recharge is unfeasible. Hence, in these areas, digging pit shaft method of recharge has to be carried out. The construction of percolation dam. Whenever you have any agriculture paddy field, if you have any chance to save the water, rainwater, you have to make a pit and then you will be able to experience. You see, even the water level, water table from here, you see the wetness of the water table. So the water which was there up to this level couple of days before and then it has gone down. What does it mean? That it means the recharge is happened here. Number of percolation dams and artificial lakes may be created to improve the groundwater storage. By constructing the above feature, the surplus water during flood season in the form of runoff can be checked and further percolating into the ground. In this way, the percolation dams and artificial lakes can act as good recharge areas. Hence, number of wells may be sunk in and around this. This is called seepage tank. And you also will be do injection or recharge well, which I have shown in the slides, in the previous slides. You can make a pit and you can make a borehole and then send the water to the subsurface to arrest the seawater intrusion. Most of the coastal areas which I have already cited also. So, injection well defined as a bore well that admit water from the surface to the underlying aquifer. If the water is recharged through a well into underlying and unconfined aquifer, a cone of recharge, you see the cone of recharge also I have highlighted. So, this method includes injection of water through vertical or horizontal bores. This method of recharge is carried out in coastal regions to prevent the seawater intrusion. This is what I said. Incidental and unplanned recharge. The water is mainly used in a day-to-day activity of human life. It is used for domestic, agriculture, industrial purposes. When the water is used for the above purposes, the same is returned to the underground aquifer by means of percolation or infiltration. But we have to be very careful. We should not send the bad water into the subsurface to destroy the existing already good water. Yes, that we have to be very careful. We can do little bit of process like filtration and all, and after that you can send it to the submergible pump, and then maybe through that the water can be sent it to the incidental and planned recharge. Unplanned recharge may be through irrigation septic tank, sewers, waste disposal and reservoirs, but be careful that the water quality has to be maintained perfectly. Induced recharge, what does it mean by induced recharge? Look at this figure. There is a river, and when you put a bore, and the water from the river will collect for your bore instead of water table, so that your groundwater system will not disturb. This is called induced. From river you take water, pump the water, infiltration flow path. There is no issue at all. Instead of taking water from the ground, water table, it is carried out withdrawing groundwater adjacent to river or lakes. Normally, this is found in sandy formation. Otherwise, you know that the water will not move very fastly from the river. Organic matter and pathogenic bacteria. No, induced recharge furnishes water free of organic matter, pathogenic bacteria and all disease-producing bacteria. The induced recharge has the advantage of simplicity and low cost. Yes, because you are now going to do near the surface, there will not be any issue at all. Coming to the spreading method, there are 5 methods are there. We will see one by one. The most widely practical artificial recharge method is water spreading. Look at this figure, it's very clear. This is a basin, natural basin. So you divert the water when excess water flows nearby this area and allow your system to get into your water table. What is the advantages? Water may be recharged through by releasing into a river basin, into a basin like structure. It is natural structure. A portion of flood can be stored in a basin. Yes, when flood comes, you can divert and then keep your water here. So, thereby regulating the flood also. It utilizes most of the area for recharge except the top of the bunds. Irregular land surface can be used without much preparation. Yes, you don't need to prepare much. Irregular lands, maybe you can prefer to make a structure like this. Even the still laden water can be used, especially when the upper basins are used for desilting and cleared at a regular level intervals. Construction of bund is very simple by using locally available material. You just make a very small bund. This is the bund, you see. It means you make a little height of this terrain so that the water will stop for some time. Whatever it is available nearby, you do it. This is another interesting runoff which is coming here, and this is the sediment, this is a clay layer, this is a foreberry, and you just make if there is a small hill is here, you just make a hole, and then this will go and it forms a bigger area, naturally available basin, so that infiltration takes place at this domain. Channels, normally in our villages we have seen small channels, that through which the water will go, and then we will take the water for agriculture purpose. So this is also a big source of artificial recharge. The method is used individually or supplement with the basin method. You can take the water from the basin also. This method involved upstream management of stream flow as well as channel modification to enhance infiltration. The channel modification may include widening, leveling, sacrificing, and ditching. This method is suitable for irregular areas and where slopes are too steep for basin construction. And you can make a ditches for the water to stay for some time over here, and then you see make a ditches wherever you have irrigation land is there. And the ditches could be able to used as a recharge zone. Stop water for some time here. The water is recharged through a series of ditches and furrows with maybe between 0.3 to 1.8 meter that are shallow. It's very shallow, flat bottomed and closely spaced. It is that spacing is very close. On very steep slopes, checks may be placed in between the ditches to minimize the movement of water or the erosion. At the lower end of the site, a collecting ditch is needed to convey the excess amount of water which is passing in the channel. It is a flooding method. Whenever flood comes, you stop the water here. Flooding method is suitable for relatively flat area. If the area is flat where the topography is not spotted, compared with other spreading method, flood spreading cost least for land preparation and grade, because you are not going to do it only the buds or you have to construct. It also covers a larger area. And irrigation method, because your land is already, it is set for planning, and then whenever you get excess water from the cultivated land may be recharged into the subsurface aquifer. You see, you take the water and then stop it for some time, but the distribution system is already installed because already you have made your agriculture land is in practice. But the possibilities of the effect of leaching action of the percolation water, removing soil nutrients is more, and thereby reducing the crop yield. Sometimes what will happen, penetration it takes the soil fertility also into the subsurface. So with this, the discussion with respect to artificial recharge is come to an end. Thanking you.